Transhuman miners, the future of human-machine integration in mining. Defining the future. Why human-machine integration matters in mining. This video explores the intersection of human-machine integration and transhumanism in the mining domain. Human-machine integration involves enhancing human abilities through machines, such as wearable technology, exoskeletons, brain-computer interfaces, BCIs, or smart PPE, enabling seamless collaboration between human judgment and mechanical precision. Transhumanism, in contrast, advocates for using advanced technologies to transcend human physical and cognitive limitations. These concepts hold particular significance in mining, a high-risk, physically demanding sector where productivity, safety, and resilience are essential. Wearable suits that reduce fatigue, AR-enabled helmets delivering real-time data, and remote-controlled machinery via BCIs can mitigate human exposure to hazards like extreme heat, gas, and heavy equipment. By augmenting human capacity, technology can keep people central to operations while reducing their vulnerability. As automation expands, integrating human intelligence through augmentation becomes a strategic necessity, ensuring critical thinking, safety oversight, and adaptability remain human strengths. However, this transformation also raises complex ethical and organizational challenges. Issues around worker surveillance, cognitive privacy, and displacement must be carefully managed. If augmentation is used to replace rather than empower workers, it risks amplifying inequality. The opportunity, however, lies in achieving a safer, more inclusive, and productive industry where humans and machines complement one another to deliver the mines of the future. In this presentation, we will examine the technologies, trends, futures tools, and policy considerations shaping this transformation. Key technologies and innovation pathways. A range of emerging technologies is redefining the relationship between humans and machines in the mining sector. Neural interfaces, particularly brain-computer interfaces, BCIs, are advancing rapidly. Devices like Neuralink's implantable chip and Synchron's Stentrode are already in human trials, allowing users to control digital systems via thought. While initially aimed at restoring function in paralyzed individuals, these technologies signal future applications in controlling machinery in hazardous environments without direct physical input. Exoskeletons are being developed for industrial and rehabilitative use. Hyundai's passive Expel shoulder vest supports arm movement during overhead tasks, while Exobionics continues to enhance wearable suits that reduce strain and improve mobility. These systems offer potential in reducing injuries from repetitive, strenuous mining activities. AR and VR platforms are revolutionizing training and maintenance. Augmented reality headsets display real-time, hands-free guidance, while virtual simulators replicate hazardous environments for safe, immersive training. Companies like Rio Tinto and Anglo American have scaled these tools across global operations, enhancing hazard awareness and procedural accuracy. Cognitive augmentation is an emerging field where wearable tech enhances attention, memory, or motor control. Experiments have shown that users can operate a third robotic limb via breath signals, demonstrating the brain's adaptability to novel control interfaces. Mining R&D initiatives are embracing integration. Rio Tinto's autonomous fleets and Anglo's enterprise VR platforms exemplify how major players are embedding human-machine collaboration into safety, training, and operational excellence. Expert perspectives from 4 fronts. Academics. Nick Bostrom of Oxford University frames transhumanism as a natural progression of Enlightenment thinking, using science to improve human intelligence and longevity. He envisions a future where brain-computer interfaces, BCIs, interconnect human minds, potentially forming a collective superintelligence. However, he cautions that such capabilities must be guided by strong ethical governance to avoid misuse. Professor Kevin Warwick, a cybernetics pioneer, supports human-machine integration and has personally experimented with neural implants. He views enhancement technologies as desirable, arguing that improving physical and mental performance is a logical and beneficial step. Other academics offer a more critical perspective. Bioethicists warn that unequal access to enhancement technologies could create deep societal divides, with the risk of forming a two-tiered society of augmented and non-augmented individuals. This highlights the need for equitable frameworks and responsible deployment. Futurists, consultants, and think tanks. Futurist Ray Kurzweil predicts that by 2045, humans will merge with AI, achieving exponential gains in intelligence and lifespan. He promotes brain implants and nanotechnology as pathways to this future, and advocates for universal basic income to mitigate job loss. McKinsey & Company and the World Economic Forum acknowledge both disruption and opportunity. McKinsey forecasts up to 800 million jobs displaced by automation by 2030, while WEF anticipates a net gain in employment through new roles. WEF's Klaus Schwab labels this transformation the fourth industrial revolution, blending digital, physical, and biological domains. MIT's Eric Brynjolfsson encourages augmentation, not replacement. He asserts that AI should enhance creativity and productivity while ensuring job redesign and large-scale reskilling to support inclusive economic growth. Developers and scientists. Elon Musk, via Neuralink, aims to establish symbiosis with AI. His team has developed a brain chip to restore communication in patients with paralysis, with future goals of enhancing cognition and memory. He views this as essential to keeping pace with AI. Dr. Tom Oxley, CEO of Synchron, takes a more cautious stance. He focuses on minimally invasive BCIs for therapeutic use and warns against pushing for high-bandwidth fusion without addressing safety and medical efficacy. Neuroethicist Marcello Ienca identifies key technical and ethical challenges in BCIs: invasiveness, long-term reliability, and consent. He calls for strong boundaries between therapeutic and elective uses, emphasizing ethical oversight. Startups and industry innovators. Boston Dynamics' Spot robot exemplifies how robotics can enhance safety and uptime by handling hazardous inspections in mining. ABB has automated dangerous tasks such as explosive charging and electric truck recharging, improving efficiency while protecting workers. Globally, autonomous haulage systems now operate at scale, with over 1,000 driverless trucks reducing human exposure in open-pit mines and pushing the boundary of integration in mining operations. Trends, signals, and common misconceptions. Human-machine integration technologies are advancing rapidly, driven by market demand, innovation, and growing institutional support. Wearables and BCIs are experiencing strong growth. In 2024, global wearable shipments reached 534.6 million units, and the market is projected to exceed $100 billion by 2030. Brain-computer interfaces, BCIs, while still emerging, are gaining traction, with forecasts estimating the market will grow from $2.9 billion in 2025 to $12.4 billion by 2034. Everyday devices, such as smartwatches, AR glasses, and health monitors, are widely used to extend physical and cognitive abilities. Assistive innovations like tongue-driven control pads have already improved independence for people with disabilities, illustrating practical benefits. Tech-augmented labor is becoming standard across industries. Exoskeletons, wearable sensors, and AR/AI-enabled interfaces are being deployed to improve safety and productivity. Global exoskeleton revenues are expected to reach $25.9 billion by 2037. Mining companies now trial powered suits for lifting and real-time exposure monitoring, while manufacturing increasingly uses mixed reality for training. These developments indicate a shift toward collaborative human-machine workflows. Augmentation is becoming mainstream. Policymakers and institutions are developing ethical frameworks to govern its use. For instance, European bodies discourage making implants mandatory for employment. Regulators are beginning to treat enhancement tools as practical assets, not speculative risks, reflecting growing acceptance of industrial transhumanism as part of the fourth industrial revolution. However, misconceptions persist. Some view transhumanism as dystopian, yet most current enhancements serve practical, safety, or medical needs. Others believe AI will replace humans, though experts emphasize augmentation over replacement. Lastly, these technologies are often wrongly seen as military or medical only, despite their increasing relevance in everyday industrial settings. Futures tools and frameworks in application. Human-machine integration in mining can be better understood through key technology futures tools. The S-curve model illustrates the adoption pattern of emerging technologies. Human augmentation in mining is moving from early experimentation to a growth phase. Exoskeleton trials show promise for reducing strain during lifting, yet issues like fit and cost remain barriers. Similarly, virtual and augmented reality (VR/AR) training has evolved from pilot stages to active use, offering immersive hazard simulations and procedural guidance. These trends suggest we are entering the steep growth section of the S-curve as performance improves and organizational acceptance grows. Moore's law, predicting exponential growth in computing power, has driven the miniaturization of mining wearables. Today, compact biosensors and environmental monitors are embedded in helmets, vests, and equipment, providing real-time data on operator health, air quality, and equipment performance. These sensors enable predictive maintenance and immediate safety interventions. The Futures Triangle highlights three forces shaping mining's evolution. The pull of the future is the vision of fully augmented workers using AR, BCIs, and exosuits. The push of the present includes safety mandates and labor shortages. The weight of the past reflects organizational inertia, cost sensitivity, and ergonomic concerns that slow adoption. Together, these tools provide structured foresight into a mining sector on the brink of transformative augmentation. Forecasting the future: exploratory and normative insights. Exploratory forecast. The future of mining, if current trends persist, points to a high automation environment where AI, wearables, and immersive training redefine the workforce. Autonomous haul trucks, drones, and loaders operate continuously, significantly reducing human exposure to dangerous tasks. Brain-machine interfaces, BCIs, may enable thought-controlled operations, building on early EEG-enabled helmets already used to detect fatigue with over 90% accuracy. Wearable sensors and smart helmets will monitor vital signs and environmental conditions in real time, triggering preventative alerts. Augmented and virtual reality, AR/VR, Training tools, like holographic safety simulations, will become standard for hazard recognition and procedural learning. These technologies improve safety and productivity, but raise privacy and surveillance concerns if not properly governed. Normative forecast. The preferred future integrates human dignity, agency, and inclusion into the adoption of augmentation tools. Ethical governance, such as OECD's call for cognitive liberty, will ensure workers consent to neural monitoring and can access or delete their data. Some jurisdictions already classify brain signals as sensitive personal information. In this future, human-centric design is key. Technologies support workers rather than replace them. Miners are trained in digital tools through structured digital citizenship programs. Governance frameworks enforce voluntary participation, transparency, and career progression, ensuring augmented mining strengthens, not displaces, the workforce. Wildcards. Several disruptive risks could derail progress. A public or legal backlash might limit or ban neuromonitoring tools. A failure in autonomous systems could undermine trust and halt deployments. Most seriously, a neural data breach could trigger widespread ethical and legal consequences, underscoring the need for robust security and informed consent protocols. These scenarios highlight the importance of thoughtful forecasting and proactive policy design in guiding mining toward a responsible, technologically advanced future. Impacts on organizations, society, and the environment. Organizations. Automation and AI are significantly enhancing productivity and safety across mining operations. Connected equipment and IoT platforms allow real-time monitoring, predictive maintenance, and improved decision-making. Studies show clear safety gains by removing workers from hazardous zones, but these benefits demand updated HSE frameworks. Digital twins, for example, simulate mine environments to support risk analysis and compliance. However, implementing these technologies requires substantial investment in workforce training. Veteran miners must develop digital fluency and learn to manage increasingly complex automated systems. Society. Human augmentation raises ethical concerns around identity, consent, and inequality. While new technologies create high-skilled roles in robotics and AI, they also reduce demand for traditional labor, especially among less tech-savvy workers. Retraining and inclusive education are essential to ensure that workers are not left behind. Moreover, transhumanist technologies risk exacerbating the digital divide. If only affluent communities or companies can afford augmentation tools, existing inequalities could deepen. Conversely, inclusive technologies, such as assistive wearables, can empower disabled or marginalized workers, fostering broader workforce participation. Environment. Automation reduces human exposure to dangerous conditions, but it introduces environmental challenges. Electrified fleets and remote rigs lower emissions and improve operational safety. However, the increased use of electronic devices, sensors, wearables, and network hardware contributes to growing volumes of e-waste. A 2024 UN report estimated 62 million tons of global e-waste, with only 22% recycled. Mining's shift toward tech-heavy operations must therefore be matched by sustainable waste management practices and a circular economy approach to technology deployment. Policy and strategic pathways to a preferred future. A responsible future for human-machine integration in mining requires forward-thinking policies and inclusive innovation strategies. Policy pointers. As augmentation technologies advance, regulators must address ethical, legal, and safety gaps. In-body wearables and brain-computer interfaces, BCIs, remain largely unregulated in employment contexts, exposing workers to privacy and consent risks. Emerging neuro-rights frameworks advocate for cognitive liberty, ensuring employees have the right to accept or reject augmentation without coercion. Employers must be legally required to offer informed consent, guarantee data protection, and maintain transparency in AI systems. Occupational safety standards must evolve as well, addressing new hazards linked to AI-driven workflows, such as over-reliance, fatigue, and cognitive load. Mandatory retraining and upskilling policies will be essential to support workers affected by technological shifts. Strategic approaches. Public-private innovation hubs can drive ethical integration. A strong example is Sibanye-Stillwater's DigiMine initiative, which partners with academic institutions to co-develop safe and effective mining technologies. Globally, multi-stakeholder alliances such as the World Economic Forum's AI Governance Alliance promote ethical frameworks for AI deployment across sectors. Regionally, Africa's 2024 AI strategy calls for inclusive, rights-based approaches aligned with local values. At the 2025 Africa AI Summit, governments pledged $60 billion toward ethical AI research and skills development. Together, these policy and strategic measures guide the sector toward a preferred future, one where human dignity, safety, and shared prosperity are upheld as foundational principles of technological advancement. Conclusion. Human-machine integration is rapidly transforming mining through technologies like exoskeletons, BCIs, wearables, and AR. These tools offer significant gains in safety, productivity, and human capability, but also raise critical ethical and governance challenges. Drawing on expert insights, trends, and foresight tools, we've explored both the risks and opportunities ahead. To ensure a responsible future, mining must adopt ethical frameworks, invest in inclusive training, and foster collaboration across sectors. The goal is not just innovation, but a future that is human-centered, safe, and sustainable.